Hi, hello, this is Catherine. This is my seventh experiment, that is ensemble based classification. Here I have the data set of retrieve golf, and I took my data set and I choose random forest. The random forest, the operator which generates a set of specified number of random trees, that is, it generates the random forest, and the resulting model is voting model for all the trees. And the generates a set of random forests. The random trees are generated in exactly the same way as the random tree operator generates a tree. Here in the apply model which takes the some for it's already trained on an example set where the informations are related to the example set and is learnt by the model. Then that model can be applied to the another example set, usually for prediction. All needed parameters are stored within the model object, and it's compulsory that both example sets, here these both example sets should be have the exactly these both example sets should have the same number, order and type and role of the attributes, and these properties of metadata of the example sets are connected to the apply model. And here the apply model is connected to the result. The example set is connected to the random forest, and the random forest model is connected to the apply model. And here the next input of retrieve golf test set is connected, and its output is connected to the result. When we run this, we get a table where we have 14 columns. To play, we can check the predictions play, confidence play, confidence and confidence yes or no. It's checked with the outlook, temperature, humidity and wind. If wind is false and the sunny outlook is sunny, then we can play. If the wind is true, the outlook is overcast, then the play is no. Like checking each and every column, and the play will display yes or no over here. And in the design part, we are going for the next, that we have retrieve golf and the cross validation operator. The cross validation is nothing, it's in order to estimate the statistical performance of an learning operator. It is mainly used and how to estimate the model. And it is also a nested process, and it has two sub process. By clicking on the right bottom corner in the cross validation, that is blue image, double click it, then we have two processes. We have the validation of two process. One is training, the another one is testing. The training model is applied in the testing process, and the trained model that is applied in the testing process here. And the performance of the model is also measured during the testing phases. Here I have the bagging it's bagging it's a cross it's a bagging is a machine learning ensemble meta algorithm. It's a meta algorithm to improve the classification and regression model in terms of stability and classification accuracy. Here the input is connected and the output is connected to the model, and the model of the input is taken into the apply model, where the apply model is the same. Here we can like explained before, it's the informations or related to the example set is learned by the model. Then that model can be applied in the another example set, usually for the prediction. All the needed parameters are stored within the model objects. And here going for the performance, these performance, it delivers the list of performance criteria values, and these performance criteria are automatically defined in order to fit in this example set. Here when running this, choose here in bagging we have the bootstrap aggregating is a machine learning ensemble meta algorithm to improve classification and regression models in terms of stability and classification accuracy. Here I take the SONA data set and I took the decision tree for making decision tree to perform the metadata algorithm, ensemble metadata algorithm. Then connect the ports. Going back to the validation. I run this. Here in the apply model is connected, then going back to the process and running this. And here we get the performance vector. The performance vector, we get the accurate value of accuracy as 86.05%. And here we have two views, table view and plot view. And here in the table view we have rock and mine and class precision and class recall. And going back to the descriptions, the performance vector shows the descriptions about the table, and we have the accuracy value, confusion matrix, true, rock and mine. And it's then going back to the bagging, here we have the charts, decision trees for the bagging. Model 1, it shows the decision tree for the model 1, and model 2 same as model 3, model 4 and model 5, and it goes on. And the description is given over here for the decision tree. The stepwise, the attribute 1 attribute 11 checks with the condition, the stepwise conditions are checked with in the decision tree, and its description is given over here. Then going back to the SONA set, here choose the third thing for this experiment. Here is here I have my SONA data set. And going into the validation part, here I had add boost, that is boosting. Here the boosting operator which implements the boost ad boost algorithm, and it is used in all learners available in the RapidMiner. It is also a meta algorithm which is used for boosting, and here the same apply model which has its own model objects and performs with the both the input of example sets and the performances as well. It plays a vital role in the testing phases. And here when running this process, here I should choose validation process, and in the validation process here we have and the same ad boost is clicked. Here we choose the Sonar dataset, and the same decision tree is chosen to get the decision tree for the ensemble based classification. I choose here decision tree and connect the ports. And the decision tree is nothing but it classifies the tree with both nominal and numerical data. It generates the decision tree for classification of both nominal and numerical data. Here we go for the validation. Here we have testing and training phases, and go back to that and run this. And here we get the performance vector for the ad boost. Here we have the rock and mine with the true rock and true mine value, the class precision and the class recall. Here we have the description about the performance vector, and the ad boost here we have the graph which shows the attribute and checks with the decision tree table to reach rock and mine using that process. And same here the tree also shows the attribute values with the description of the decision tree which is given in the design part. That's all about the 7th experiment. Thank you for listening.